Hi, I'm going to analyze this distance time graph here. I'm going to find some average velocities and some instantaneous velocities. Starting with this time interval from 0 to 25. I start here at 0, I finish at 25 there on the curve. I'm going to draw a triangle for those 2 points, and I'm looking to get the gradient. So it's the change in y, which in this case is plus 15. And the change in x, which is 25, 15 over 25, that's my gradient. Another way of looking at it is velocity is distance over time. So it's change in distance over change in time. So for the first one, I do 15 divided by 25, which is 0.6. So that goes into my first box. For the next one, I'm going to get rid of that triangle and I'm going to draw a new triangle. This time between 30 seconds and 50 seconds. So I'm looking, it's quite a small little triangle there. Once again, work out the change in the distance. Now, I'm not starting at 0, I'm starting at -5. And I go up to 0. So the change in displacement this time is 5. And the time is 20. So this time, the average velocity is 0.25. Now I'm going to do some instantaneous velocities. It's not that different, but you're just given one time, 27.5. So if I look carefully, it's this point here on the line. Now, the triangle that you need is essentially, it's either a tangent if you've got a curve. So that's something for a different video, I think. But in this case, we're just going to take the biggest triangle that we can that still fits onto the straight part. So I've taken from 25 seconds up here to 30 seconds. Now in this case, the distance is going from a positive to a negative. So my change in distance is -20. And it happens over 5 seconds. So once again, velocity is distance over time, -20 over 5, which is -4. And for the last one, I'm looking at 35 seconds, which is 25, 30, 35, which is here. And that part of the curve is flat. So there is no change in the displacement. The object's not moving, so the velocity is 0.